In this lecture, I will help you to solve two questions. See, one question we had already done in the last lecture. Before that, I would like to give you a quick revision about what perturbation is. You know that I have already told you that perturbation means small changes, or basically, these are generally it means small changes, but in mechanics, perturbation means small changes in Hamiltonian. Okay, so obviously, if there are small changes in Hamiltonian, because of the change in Hamiltonian, many things will change. So I had already done one question in the last lecture, that was by the method of time dependent perturbation theory, find the first order solution for a system of a particle of mass m moving in a force-free field motion in one direction by assuming the initial condition beta naught is equals to 0. This I have already done. So, in this lecture, I will proceed. I hope you remember how we did all the solutions. It was clearly simple. First, what we did was we considered the case where there was no perturbation and we found out the solution. That is, we found out the value of x. Okay, so here was the value of x and also the value of p. What is x? X, you know, it is the position coordinate, and p is the momentum coordinate. This we had already done, right? And I found out the value of alpha 1 and beta 1. Okay, so this also we had already done. Now see the next question. What does it say? By the method of time dependent perturbation theory, carry the solution for linear harmonic oscillator in force free motion through second order term. Now they are asking us to do everything for second order, right? Like in the previous question we found out the value of alpha 1 and alpha 2. Here I will do the same and I will find the value of alpha 2 and beta 2. Okay, so see, basically what you have to do is you have to solve the entire question as the previous question up to equation number 12. Up to this equation you have to solve as it is, then after that things will change. See, what you have to do is write everything up to equation number 12 of the previous problem and then continue as follows. What you have to do is you have to substitute equations 12 for alpha and beta. See, I have got the value of alpha 1 and beta 1. You have equation number 10a and 10b. Okay, over here we have alpha and beta. Also in 10b we have alpha and beta, and this gave us the value of alpha dot and beta dot. Now the entire thing will be same, but what you have to do is instead of considering alpha dot, you will consider alpha 2 dot, and here it would be beta 2 dot. Okay, beta 2 dot and alpha 2 dot, and in the right hand side, in spite of alpha, you have to use alpha 1, and instead of beta you have to use beta 1. Okay, instead of alpha you have to use alpha 1, and instead of beta you have to use beta 1. So we have the values of alpha 1 and beta 1 in this equation number 12. We have the values of alpha 1 and beta 1. So we will put in the right side of equation number 10, and over here the values would be alpha 2 dot and beta 2 dot. See what I'll get. I got the value of alpha 2 dot and the value of beta 2 dot. Okay, and here instead of alpha I have taken alpha 1, beta 1, and here also alpha 1, beta 1. Now you have the values of alpha 1 and beta 1 in equation number 12 of the previous question. You just substitute it. So substituting the value of alpha 1 in alpha 2 dot, see what I'll get here. Alpha 2 dot will, I will substitute the value of alpha 1 and beta 1 from the previous question. So this is the value of alpha 1 and this is the value of beta 1. See, after using this I will solve. What I will get, what you have to do is you have to take alpha naught omega square common from the entire equation. So alpha naught omega square common, if you will take this common you will get this in your bracket. Okay, uh, I think here there is some misprint. because here should be omega square and here should be omega t cube, and this m should not be here. So finally what I will get, minus alpha naught omega square in bracket t minus omega square t cube by 2 plus omega square t cube upon 3. Now you can solve further. After solving the bracket, you will get this term. So in this way you have got the value of alpha 2 dot. Similarly, you can find the value of beta 2 dot. Now here similarly you will replace alpha 1, alpha by alpha 1 and beta. See, you will put the value of alpha 1 and beta 1 by equation number 12 of the previous problem. So finally, after replacing alpha 1 and beta 1, we will reach here. In similar pattern as we did in the case of alpha 2 dot, you have to do here. You have to take alpha naught omega square upon m common. You will get this in the bracket. After solving these two terms, you will get this term, and finally equation number 14b will give us the value of beta 2 dot, which is alpha naught omega square upon m in bracket t square minus omega square t to the power 4 by 6. So basically this is equation number 14b. So equation number 14 a gave the value of alpha 2 dot, and equation number 14b gave the value of beta 2 dot. Now obviously we had already done in the previous this thing example also. When I was finding alpha 1, how did I find alpha 1? I just integrated alpha 1 dot and alpha 2 dot, and when finding the solution you have to take alpha naught minus integration. So here also when you have to find the value of alpha 2, you will integrate alpha 2 dot using the initial conditions, right? So this is what you will get after integrating alpha 2 minus, if you see integration of this term with respect to t, this t would be t square by 2 and here would be t to the power 4 by 4. 6 into 4 would be 24, and hence after integrating 14a you will finally get the equation 15a. Okay, after integrating, you will get the equation 15a, which would be the value of alpha 2. Similarly, in order to get beta 2, you have to integrate 14b with respect to t. See here, that would be t cube by 3. And after integrating this term, it would be t to the power 5 by upon 5. 6 into 5 would be 30, and finally you will get these terms, and henceforth you have got equation number 15b, which will give you the value of beta 2. Now you have the value of alpha 2 in equation number 15a, and you have the value of beta 2 in equation number 15b. Okay, now we had to find the solution. For solution, you they mean that you have to find the position coordinate, also the momentum coordinate. Hence we had seen the value of x. So when I considered the case in which there was no perturbation, that time we found the value of x. See, previously I have already done this. See, in equation number 6 of the previous question we had found the value of x. Same value I will write here, but instead of alpha I have alpha 2 and instead of beta I have beta 2. So replacing the values of alpha by alpha 2 and beta by beta 2, this would be the value of x. So you have the value of alpha 2 in equation number 15a, and you have the value of beta 2 in equation number 15b. Just replace them, and finally you will get this equation. Now you have to solve it further. So solving it further will give you this equation. Now what you have to do is, you just have to take alpha naught m omega common, and you have to take this in one bracket. After solving this, all these equations, see, this and this can be solved together, and even these terms can be solved together. So finally after solving them, you will get this equation, which is alpha naught upon m omega in bracket omega t minus omega cube t cube upon 6 plus omega to the power 5 t to the power 5 upon 120. We know that 6 is nothing but 3 factorial and 120 is nothing but 5 factorial. Hence, replacing 6 by 3 factorial and replacing 120 by 5 factorial, you have equation number 16a. Okay, and in order to find the value of beta, that is nothing but p, which is the value alpha 2, here is the value of alpha 2. Okay, so finally 16a will give you the value of x and 16b will give you the value of beta, that is p. Okay, I hope this question is quite clear. If it is not clear, I will take the next question which is very much similar to this question. Okay, see what does the next question say. By the method of time dependent perturbation theory, carry the solution for linear harmonic oscillator in force free motion out through third order terms. Now we have to solve entirely just as the previous question, just in case of alpha 2 and alpha 3. I want the value of in case of alpha 2 and beta 2, I want the values of alpha 3 and beta 3. So what you will do? Same. See, we'll substitute equation number 15 for alpha and beta. Where is my equation number 15? Yeah. In these values, you just have to make some changes. See what they are saying. Write everything up to equation number 15a of the previous problem and then continue as follows. Now substituting equation number 15 for alpha and beta on the right hand side of equation number 10. Finally, you will have this value. See, as I have told you already, we have done in the previous question also. Here, now in place of alpha dot, I have to write alpha 3 dot, and here would be alpha 2 and beta 2. The right hand side, instead of alpha and beta, you have to replace it by alpha 2 and beta 2. Hence, here would be alpha 2, here would be beta 2, and I will get the value of alpha 3 dot. Similarly, I will get the value of beta 3 dot. All these are simple calculations. See over here, in order to find the value of alpha 3 dot, I have replaced alpha 2 and I put the value of alpha 2 over here from the previous solution. See, in the previous question I had a value of alpha 2, that is equation number 15a. From equation number 15a you put the values of alpha 2, and over here after putting the values of alpha 2 you will get this, and after putting the values of beta 2 you will get this. Solving it will give you alpha 3 dot as this. See, it's quite simple. You just have to solve few things. And here finally in equation number 17a, you have the value of alpha 3 dot. Okay, similarly you can find the value of beta 3 dot. Here you have omega squared t, and after solving this everything you will get the value of, just it is like totally similar to the previous question. Okay, after solving this finally you will reach to this stage which will give you equation number 17. So equation number 17a will give you the value of alpha 3 dot, and equation number 17b will give you the value of beta 3 dot. So finally you have alpha 3 dot and beta 3 dot. Obviously you will integrate it with respect to t and you will get the value of alpha 3 and beta 3. After integrating equation number 17a with respect to t and take using the initial conditions, you will get alpha naught minus integration of all these things. Here would be t square by 2, here would be t to the power 4 by 4, and here would be t to the power 5 by 5. So obviously 4 into 6 will give you 24, 6 into 120 will give you 720, and these would be the numbers in the denominator. And similarly you can solve it for the integrate beta 3, that is equation number 17b, and finally you will get the value of beta 3. Here would be t cube by 3, here it would be t to the power 5 by 5, and here would be t to the power 7 by 7. So 3, 30 and 840 would be the answers after multiplying this, and hence you will get the value of beta 3 and alpha 3. After similarly, like just in the previous question, what we did, we put the values Like we had the value of x, no? So instead of alpha, you replaced it by alpha 3, and instead of beta, you replaced it by beta 3. Same things you have to do over here. Here would be alpha 3 and here would be beta 3. After replacing alpha 3, you will get this equation, and replacing beta 3, value of beta 3, you will get this equation. Hence, alpha naught upon m omega, after taking common, you will get this in the bracket, and here also alpha naught into m omega, you have to take common, and you will get the final solutions. So here I have already reached. See, after taking alpha naught m omega entirely common, you will have these things in your bracket, and I will reach to this equation. Okay, now see, you can solve these both terms together, then these terms together, and finally these and these terms together. After solving it, you will reach to the next equation, that is this equation. See, observe, you have here in the denominator 6, here it is 120, and here it is 5050. So this is the value of 3 factorial. 3 factorial is 6, 5 factorial is 120, and 7 factorial is 5040. Hence finally you have got the value of x. Similarly, you can find the value of p, that is alpha 3, and this would be the value of alpha 3, and these are the required solution. See, even there are some similarities in both the solution, hence you can find the other order solutions also, like alpha 4, alpha 5, and all. See, here in the value of x, you have 3 factorial, 5 factorial, 7 factorial, and you have the terms and the alternate signs minus and plus. Okay, this is going up to 7 factorial. But if you see in the previous problem where we had find the value of alpha, like x, okay, here there was 3 factorial and here 5 factorial. So continuing it, you will get the value of alpha 4. See, how will you get the value of alpha 4? Not alpha 4. How will you get the solution up to fourth order? So the value of x would be alpha naught upon m omega in bracket omega t minus omega cube t cube upon 3 factorial plus omega to the power 5 t to the power 5 upon 5 factorial minus omega to the power 7 t to the power 7 upon 7 factorial plus omega to the, see, here there are odd terms. Now after 7 we will get the ninth term and with plus sign. So plus omega to the power 9 t to the power 9 upon 9 factorial. In this way you can find the value of alpha 4 x, that is the fourth solution, fourth order. Okay, and similarly, in order to find the value of p, here there is p. So up to 4 factorial we had in the second order. In the third order, see, we had up to 6 factorial. See, we had up to 6 factorial. Now in order to find the value of alpha 4, it would be alpha naught in bracket 1 minus omega square t square upon 2 factorial plus this term minus this term. And there would be one more term, that would be plus omega to the power 8 t to the power 8 upon 6 factorial. I hope everything is clear. Now in the next lecture, what I am going to teach you or explain you is the period of playing pendulum with finite amplitude. This is the concept I will take in the next lecture.